Going to be revising linear equations in chapter 2. This should not be anything new. If you, so I want only going over a few examples here. So the first question, we've got solve the following linear equations. We've got x plus 2 over plus x over 2 minus x plus 1 over 4 is equal to 1. So the first thing we need to be thinking about is what would our lowest common denominator be? So in this case here, 3, 2, and 4, that both goes into 12. So I would need to be timesing 3 by 4, 2 by 6, and 4 by 3. So remember, we need to do exactly the same thing to the numerator as well. So I'm just going to rewrite my fraction as individual fractions. So that just means I'm going to make sure that I also keep my brackets here. So I'm going to put brackets and everything on the numerator when I rewrite it. So the next step after I've done this is I'm going to expand my brackets. So there's one thing I will do, I'll show you in a minute. So that just means I'm going 4 times x is 4x, 4 times 2 is 8, and I'm going 3 times x is 3x, and 3 times 1 is 3. One of the things you'll notice that I've done is I've kept this one in brackets just because I've got a takeaway sign right here. Because I've got that takeaway sign needs to be applied to both 3x and 3. So I'm going to rewrite this as one bracket now. And now I've got negative 3x and negative 3. The next step is I'm going to look at, do I have anything common that I can simplify? So straight away here, I've got 6x plus 4x is 10x minus 3x is 7x. And I've got 4 and negative 3. So, sorry, 8 and negative 3. 8 take away negative 3 is 5. Now I've got something simple. 7x plus 5 over 12 equals 1. I'm just going to times both sides by 12. And I get 7x plus 5 equals 12. Then I'm going to take away 5 on both sides, and that will give me 7x equals 7, and then I'm dividing by 7, and that will give me x equals 1. The next question is solve the following linear equation. I've got 2/3 in brackets x minus 6, take away 2 over 3 in brackets x plus 4 is equal to 1 plus x. I hate the way these equations are written, so I'm going to fix them. So we know when we have something here next to a fraction, it's really timesing with your numerator. So I'm going to rewrite that as 2 in brackets x minus 6 over 3. And I will do the same to my other function, which will be 2x plus 4 in brackets over 3. It makes it look a bit easier for me. I'm going to expand my brackets. So I'm going 2 times x and 2 times negative 6, and 2 times x and 2 times 4. Now, one of the things that I'm going to do here, before I do that, I might rewrite it in terms of one fraction. So the negative straight away applies. So that is negative 2 times x is negative 2x, and negative 2 times 4 is negative. The next step that I will do here is I would like to simplify as best as possible. I've got 2x take away 2x, so instantly that cancels out. I'm left with negative 12 take away 8, which is negative 20, so negative 20 over 3. I'm going to get x by itself, so I will take 1. We know negative 1 is the same as negative 3 over 3. So that tells me it will be negative 20. Take away 3 is negative 23. Let's look at the next question. So this says a car traveling at 60 kilometers per hour takes T hours to go from A to B. If the speed of the car is reduced by 10 kilometers per hour, the time to go from A to B is increased by half. Now, calculate the value of T and find the distance between A and B. So what I've done just as a quick visual, our B is at the same level here, our A is at an origin. So I want it to work out where it is. So of course, we're going to, the bigger the speed, we are going to get to our location a lot quicker. So it takes less time. So one of the formulas we know that we're going to need to use, because we're talking about speed, talking about time, is speed equals distance over time. So I'm going to use that for both my formulas. So the first formula that I'm going to have is I've got 60 kilometers as my speed. So 60 kilometers is distance over time. Now, the next part, the next equation I'm going to create is looking at what is my new speed. So it says if the speed of the car is reduced by 10, that means my speed will be 50. I increase the time by half an hour. So because with our speed, we're saying kilometers per hour, I need to write half an hour as 0.5 of an hour. So I write it as 50 is equal to D over T plus 0.5. On my first equation, I'm just going to get D by itself. So to do that, I'm just going to times by T. Now we've got two equations. We can use our understanding of simultaneous equations. So simultaneous equations just means we can substitute. So I will substitute into this D 60T. So that gives me 50 is equal to 60T over T plus 0.5. The next part is I'm going to take the bottom to the other side. So that will give me 50 in brackets T plus 0.5 equals 60T. And then the next step is I will expand. So this will turn into 50 times T is 50T, and 50 times 0.5 is 25. I can then get my T onto one side. So I will take away 50T, and that will give me 50T is equal to 25. I will then divide by 10, and that will give me T is equal to 2.5 hours. So we know the hours it's going to take, but we just don't know the distance. So if I wanted to find the distance here, I just need to substitute 2.5 into this equation right here. So I'm going 60 times 2.5, and that will give me 150 kilometers. The next question that we are going to look at is the temperature measured in degrees Celsius, C, is linearly related to the temperature measured in degrees Fahrenheit. Water boils at 100 degrees or 212 Fahrenheit and freezes at 0 degrees or 32 degrees Fahrenheit. As we know, it's going to be linear between these two amounts. It does make our job easier because we can say we've got two coordinates. So let's identify the gradient between them. So I'm just going to list them both down as x2, y2 and x1, y1. I will substitute them into my equation, and it gives me 212 take away 32 over 100 take away 0. I'll simplify them, and that will get me 9 over 5. I simplified that using the cache, that's why I could do it so quickly. The next part that I need to do is if I'm wanting to find the linear equation, I'm going to use point intercept form. That means I'm using this part of the gradient. This would have been taken over, and it would have been m in brackets x minus x1 equals y, take away y1. The next part, I'm just going to substitute my information. So straight away, we know our gradient. Our gradient that we have is going to be 9 over 5. Another thing you would have noticed I've done, I've changed my x's to Celsius and my y's to Fahrenheit, just so we've got that clear relationship between them. I'm going to substitute in 9 over 5 my gradient, and I've picked this point here for my C and for my Fahrenheit. So C and F. All I need to do now is simplify this. 9 over 5 times C is 9 over 5C. 9 over 5 times 0 is just 0. So I'll leave that. Now I just plus 32 to both sides, and I get F by itself. So that means my equation for Fahrenheit is 9 over 5 Celsius C plus 32. I've drawn a picture just so we can visualize. So this question, a householder's electricity bill consists of a fixed payment together with an amount proportional to the number of units used. When the number of units used was 1,428, the total bill was $235.90. And when the number of units was 2,240, the bill was $353.65. How much will the householder's bill be if 3,050 units are used? So we've got two coordinates. We're focusing on the variables of units and cost. So the first one, we've got 1,428 units for the cost of 235.9. And the next one is we've got the units 2,240 to 353.65 in terms of cost. So because we've got 2 points, we know they're linear. It means we are going to use the gradient formula. So I'm going to substitute my values in. So just so you're aware, I have made this one here, x2 and y2, and I've made my first one, x1 and y1. So I substitute those values into my formula and I simplify. I put it as a decimal just so it's a lot easier to look at because it's terminating. So my gradient is 0.145. The next step that I'm going to do, I'm going to use point intercept form. Point intercept form means that I need my gradient and I need one of the points. So I'm going to use my first point just because the numbers are smaller. So that means my m is 0.145, my x1 will be 1,448, and my y1 is 235.9. I just need to simplify this. To do that, I'm going to expand. So 0.145 times x is 0.145x, and 0.145 times negative 1,428 is negative 207.06. So now I've done that, I took the negative 235.9 to the other side, so it becomes plus, and I just have one last thing to simplify. That will give me my C value of 48.84. So now I've got my equation, y equals 0.145x plus 28.84. So my x is my units and my cost is my y. So the question originally asked me, how much will the household bill be if 3,050 units are used? I just need to plug that into an x value. So if I put that into an x value and solve it, I will end up with $471.09.